Coastal processes are pivotal to our understanding of our environment because they involve the interactions of the oceans, 70% of the Earth's surface, with human-inhabited continents. There are two types of coastlines, active coastlines and passive coastlines. Active coastlines feature high cliffs, a narrow continental shelf, and a steep drop into the deep ocean. Active coastlines occur when a fault line lines up with the edge of a continent. Passive coastlines feature wide, sandy beaches and a much slower drop into the deep ocean. They occur on passive continental boundaries. Wave movement occurs with the flow of wind across the water's surface, as we're mimicking here with the spoon, which initiates a circular motion that gets smaller as the waves get deeper. Wave breakers occur as the water gets closer to the shoreline and the water gets shallower, disrupting the circular motion of the waves. Here, we mimic wind movement with the spoon, and we can see that as the breakers hit the coastline, pieces of the coastline begin to break off and fall into the water. As climate change contributes to glacial melting, sea levels are rising. This threatens new areas of land with coastal erosion as water moves more inland, demonstrated by the water being added here. Coastal erosion can be exacerbated by weather events. For example, during a storm surge, high winds and decreased air pressure cause water levels to rise above the high tide mark, endangering both infrastructure and people. Sea level rise can make storm surges worse. Various coastal engineering techniques can be used to slow coastal erosion. For example, breakwaters and seawalls can be built to provide a better barrier between water and coast. Beach nourishment is another option, this one involving the addition of extra sand and sediment to beaches to compensate for erosion. Living shorelines have also been used to stabilize coasts and involve using natural materials such as plants and rocks to strengthen coastlines. Worst estimates predict that by 2100, the increase in sea level rise will cause 30 to 70% of U.S. coastal wetlands to flood. Although coastal engineering solutions exist, without a slow in climate change and sea level rise, these solutions will ultimately be ineffective.